All right. So now let's move to the details of the program that we wrote together or we explained to you and see more details about it. First thing is about MPI init that I already talked about it, and there's honestly not much to talk about it. We should just use it as is because it just initializes MPI and enables us to work with its instructions. The only point that you need to know at this point is that uh, no instruction can be used, no MPI instruction can be used before MPI init. And after that, you can, once the MPI init is done successfully, uh, from that point onwards, you can utilize MPI commands. All right, I told you that one of the main things that MPI init does is creating the communication world, basically identifying all the processes that are built that are going to communicate with each other, and by default it gives it a name called MPI com word that is very often used. I have not seen many instances that subgroups or subsets of processes are built. So we generally use this MPI convert. All right. So in the first point, you can see that MPI init defines the communicator called MPI convert. And so we need it for every single communication. We can imagine MPI convert as something like this, where each circle represents a process that is given a number, which the number is called the rank, and then using that rank, processes can talk to each other. Okay, so all MPI communication called a communicator argument. So that communicator is like the network between the MPI task, and that should be used for communication. So they can communicate only if they share a communicator, the network basically. List of processes. I guess I talked about most of these things. So each process has a rank. So that's the important thing, and that's used as the communicator. And a process can have multiple communicators, which is not common, at least to the extent that we discuss in this course. I guess that also I talked about. So a rank is also known as a process ID, or the way you can call or address a process in the network. Okay, so I guess I talked about these instructions before, but here we mostly focus on the communicator part. So basically you can create instances of type MPI com, which is the communicator, and then basically that com, COMM, serves as the variable that a subset of processes connects a subset of processes together. But as I said, in this part, for the most part, we do not use it. We just use MPI com word. And then the size of it just tells us the number of the processes that are communicating with each other. Not very important. The more important one is this one that determines the rank, the ID for each process. So that's why it's the important part. Okay, and the last part is MPI finalized. Let's talk about that one. I mean, there's not honestly too much to talk about it. It's just a no-brainer. It's just, okay, we are done, and no MPI command can be used after that. All right, so now let's learn a little bit more about MPI instructions via examples. So again, MPI.h has been used. That's the easy part. Main is not a MPI thing. It's more of the C part. And then few variables defined. That is just normal variables. And then MPI init, where it returns a variable and you can use that variable, check the value of it to see if the connection has been or the initialization have been successful or not. Any values except 0, any values other than 0 shows an error. That's what this block of code is doing, checking the quality, the initialization, the successfulness of the uh, initialization process. And now, because this is just a hello world, we don't have to do this, but this is a hello world, and we want to know the size of our world, size of our network, size of the processes that can talk to each other, and the rank is assigns a rank to each process. And then we just do printf that says that number of tasks is this, and my rank, which is my process ID, is this. And then this is number of tasks, and this is rank. All right, and eventually we have MPI finalized that you are familiar with. Okay, I guess we can skip this this example. It's pretty much similar to the previous one, so I'm not going to spend time on this one. It just the only difference is that it makes use of another MPI command called get processor name, and then using that command you can use MPI hostname, which is the name of the process, the processor, and then put it in the local variable which has been defined here, and then you can print it. So that is not a much difference. This is just one level, just another example. What is important about MPI is MPI Messages. So where you develop the main logic of MPI program. So essentially, for communication between processes in MPI, in addition to the COM word, we need to use them. We need to explicitly say this MPI process sends message to the other one or receive message from another one, or this MPI process send message to everyone. So these type of things are needed. So these are known as MPI Send and MPI Receive. So two very important command in MPI is called MPI Send and MPI Receive, that we are going to explain in here. But before that, I would like to mention that in MPI, when we pass data between processes in MPI, so we may pass integer, we may pass a string, we may pass double numbers, and a wide variety of things. So we have something called MPI data type, as you can see here. So when you send or receive data, you have to explicitly say the type of the data that is being transferred. So between the send and receive, the data type should match. In other words, if you send an integer, the receiver should wait for an integer. So so this is the list of the data types. I'm sure you're familiar with what they do. However, it's just good to see the list of such data types. Okay, so it's called point-to-point communication, send, receive. So when we have two processes, source process and destination process, I guess this is no-brainer, this is too easy. The communication is done via rank, which process you are going to talk to, which process you are going to send data to. So that's the rank part. And as I said, MPI send and MPI receive are two key instructions of MPI. So we have MPI send and MPI receive. Each one of them has two versions at least. One is called blocking and non-blocking. MPI send blocking, MPI send non-blocking, MPI receive blocking, MPI receive non-blocking. The difference is relatively simple. In blocking send, the send operation, the send command is blocked until the receiver acknowledges the receipt of the message. Similarly, blocking receive will move on. So basically, the program that has a receive instruction, that instruction will be passed. It can proceed to the next command if that receive uh, instruction is completed. In other words, if it does not complete the send or receive, it cannot move on to the next instruction. So you can imagine that in non-blocking is exactly the opposite. So when we do a send, so send has some implications. So the program does not wait for that implications. It just moves on, and the send, it's like a thread. The send forms a thread, and that thread does the send operation regardless of the rest of the program. So it's non-blocking. So we have non-blocking sends and non-blocking receive. So I'm not going to talk deeply about non-blocking send and non-blocking receive. We mostly focus on blocking send and blocking receive. Here you can see the MPI Send instruction that has a buffer. This is the address of the data that you want to send. This is the size of the data. This is the data type that I talked about. You have to identify the data type. This is the destination, the rank of the destination machine. And then this is tag. Well, tag is just for further coordination between the two communicating processes. I would say for the most part, you do not use it in basic MPI. In advanced MPI, of course, you use it, but in basic MPI, no. And eventually, we have the communicator, which, as I said, you have the com word as a default thing. So, and then the instruction will return a value that we can use for error checking. Similarly, we have a receive command. That is buffer is the address of the data that is received. This is the size of the data. This is the data type that I said it should match. This is the source, the source process that we expect to receive data from. Tag, I talked about it. It's more for further coordination between the sending and receiving tasks. We do not use it in this course. It's more for advanced MPI. And then the communicator, and then the status of the received message. Has it been done successfully or not? So, for example, so the value of the status can be the source process that has sent the message. So let me see what is in this slide. Okay, here we talk mostly about the usage of tag. Other than that, we explain the rest of it, like what send has to provide the destination rank. Receiver should specify the source rank, and the communicator must be the same between the sender and the receiver, which we use com word as I mentioned earlier, and the tags must match. So although we do not use tag in the level that we teach in this course, but it's good to know about it. That, for example, if we have two send commands in one process and two receive command in the other one, so how do we know which send is talking with which correspond to which receive? So the tag will be used in these circumstances to further to provide further details about the communication between the two processes. The data type must match. I talked about it, and the buffer should be large enough. Should be should match the receiving data. And then the tag part, we can bypass it by just using MPI any tag, MPI any source to bypass the source part, and we sometimes do that. All right, so here is a program that explains how to send a send and receive message that I will explain it in the next video.